Good. See? That's what? I thought that. Yeah, good stuff. I'm Marcel Jackson, a mathematician at the Trobe University. When we deal with the algebra of true and false and how these are combined using or, and not, we arrive at a situation like this. 0 corresponds to a false, 1 corresponds to a true. When you first encounter these kinds of strange logics and algebras, I guess it's not a strange logic, it's unusual as an algebraic structure, people often find it a bit confusing to have such a limited range of truth values. In reality, things are not necessarily just false and true. One of the ways to patch this up is to introduce a third truth value, unknown, or D, Dunno. How does this work? There's lots of different ways you can add don't know or unknown into this. Here is one natural way. Over here what we're doing is effectively introducing unknown as an intermediate between false and true. Don't know. So we're choosing that the negation of don't know is still don't know. These are actually used in modelling things like circuits. In circuits we have lots of trues and falses, or ons and offs, but when we try and reason about how these might work and how they perform, sometimes it's convenient to have an extra parameter that corresponds to some unknown input. It could be a 0 or 1, we just are trying to work with a situation where we're not sure. Another place where a more complicated model of truth and falsity, so where we might have something like unknown, is when we're doing database queries. So here we have an imagined database with some students, and they've got some marks. And lo and behold, this Marcel Jackson character, no one's entered a mark here. So when we query, has John Doe passed? So presumably 50% might be a pass mark, and so that statement should be counted as false. But if we query Marcel Jackson as passing, it's really unknown. It's not false, it's not true. I may have actually received 90%, in which case it would have been true, or 0%, in which case it would have been false. But in fact, we just don't know. And so these three-valued logics, like the one we've seen over there, underlie basic query languages for databases. Now, with Boolean algebra, the fact that almost any combination of zeros and ones, so any function of zeros and ones, could be written using just and, or, and not, was very important. It meant that when we wanted to display the picture for the number 2 on our calculator, we could turn on and off that switch in the way that was desired, just according to how we draw our numbers. Similarly, understanding the way that the algebra of this true, unknown and false model works is very important. And one of the mathematicians at the Trobe University, Brian Davey, and some of his students have worked on exactly this problem and given a nice characterisation of how things work.